In this tutorial, I'm going to explain how effect size, sample size, and power, how these three variables interact with each other. So let me go through the definitions very quickly. So effect size, as you can see, that there are different numbers for different size of the effect size. For instance, for colon D, 0.2 is defined as small, 0.5 is defined as a medium, and 0.8 as defined as large. And so this is based on Jacob Cohen. Actually, I have another tutorial explaining more about Cohen D, so I'm going to put a link down below and you can refer to it for more information. Anyway, so that's effect size. There are different levels of effect size. And another one is sample size. So sample size is the number of observation or individual measure or included in a study. So for instance, you run a survey, you might need to collect, like for instance, 100 or 200 people to answer your survey. So this 100 or 200 people is the sample size. And in theory, definitely we would like to have more people. It's better in generally, it's more representative. But the problem is that to collect more people or a large sample size, in generally it requires more money and time. So we need to have a regional number in terms of sample size. And another one, the last variable here is the statistical power. So the basic idea is that, so as this is alpha and beta. So alpha typically is 0.05, 95%. And the beta, so the beta 1 minus beta is the power. So let me just focus on here. Actually, I heard another tutorial explain alpha and beta more. I'm also going to put a link down below, or you can refer to that video, for more information about alpha and beta. But let me just keep it simple here. So 1 minus beta is called power. So what it means is that when H0, namely the non-hypothesis, is false, and we reject the non-hypothesis, so this is the power. So 1 minus beta is the power, which is the probability that the non-hypothesis is false, and we correctly reject the non-hypothesis. After knowing the definitions, let's just go into some use some R code and a function library PWR to illustrate the relationship, or to explain the relationships between these three variables, or these three concepts, depending how you call them. So the one thing is that the function, actually this library PWR have a function. So this is pwr.t.test. So basically we can use this function to when we determine some parameters, we can get another parameters. So for instance, we define that the sample size as 100. So notice that this n is for each group, and for two sample t-tests, we have two groups. So the sample size is actually 100, and we set the effect size as 0.5. The alpha level is 5%, and then we would like to know the power. So another one we change slightly different. The only difference is in the sample size. So we change from 100 to 140. And so basic ideas all are the same, and we only change the sample size. So the thing here we would like to know is that how sample size will impact the power, and we keep the effect size as the same. So in this tool function, we'll keep all the effect size as 0.5, 0.5, so we'll keep it the same, and we try to see that how the sample size, different sample, 100 versus 140, will impact, how that will impact power. So we say the result and then print out, you could plot a figure actually, so we plot the first result, which is the sample size for 100. As you can see there, the plot showing the x-axis is the sample size and the y is the power. And this is, so we have the sample size of 100. Notice this is the n is for each group, so this is sample size 100. And we got the power of under 75%. And if we increase the sample size to 140, we got the power above 75%. So as you can see that, for a given effect size, as sample size increase, the power also increase. So let me zoom out a bit. So to conclude that, as you can see that you will fix the effect size, namely keeping the effect size the same, then we can see that as the sample size increase, the power also increase. So this is the first component. Let's move to another one. We keep the power as the same, and then we want to see that how the effect size. So let's move to the second component, which is that we keep the powers because we have three variables. Yes. So when we talk about a relationship, we need to keep one variable as a constant, keep it as the same, and then we try to see how the other two variables interact with each other. So let me see that keep the power as the same. Let's see how effect size impact the needed sample size. And so here is that we are going to keep the power as like 0.8 and 0.8. We keep it at the same, and the only difference is we're going to change effect size from 0.5 to 0.8. So we increase it. So this is a higher effect size, this smaller effect size. So they're all relative. Yes, this 0.5 is smaller than 0.8. So this figure is the effect size of 0.5, and this figure is effect size of 0.8. Let me zoom out a bit to see. So as you can see that, so we're going to see the needed sample size. Yes. So when the effect size is 0.5, we need the sample size of 128. But when we increase the effect size, actually the needed sample size is 52. So as you can see that for a given power, as effect size increase, the needed sample size decrease. So when we have a large effect size, actually the needed sample size could be smaller. So that's the second component of this tutorial. Last, we're going to see that how the effect size impact power. We are going to keep the sample size the same. So here, these two functions is that we're going to keep the sample size as 100. So this 50/50, actually the sample size is 100 because we need to time 2. And we're going to see that how effect size, so 0.5 versus 0.8, how that impact the power. So then we put the power as a none. Yes. So this is the one we're going to would like to know. And we plot the result. Let's zoom out a bit to see the result more clearly. So I'm not fully, to have some comparison. So as you can see that this is the effect size 0.5, this is effect size 0.8. Remember that across all these all the plot, X always sample size, Y always power. Yes, so and the sample size we keep it as the same, but because the effect size are different, so the line are different. Yes, you can see that the line are different, the shape are different. And so if the effect size is larger, the line is more like moving up. Yes, you compare those two lines. So you can see that for the same sample size, then the sample size 100, yes, we can see that the power got increased. So effect size, the power is increased, yes. So the power here is almost close to 100, not yet 100 yet, but the power here is like under 75%. So as you can see that for a given sample size, here both of them are 100, then as effect size increase, the power also increase. We increase effect size from 0.5 to 0.8, the power increase significantly. Yes. So to summarize, in this tutorial, we talk about the relationship between these three variables. So for a given effect size, we will increase sample size, the power increase. The second, we talk about for a given power, as the effect size increase, the needed sample size decrease. Lastly, we talk about for a given sample size, as effect size increase. Oh, sorry, there's a typo here. I'm going to update it. Should be an S here. As effect size increase, the power also increase. So I think that's it. Thank you for watching. If you have any questions, feel free to comment down below. I will do my best to answer the question you might have. Okay, thank you for watching.